All right, next example. A farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders on a river. If the farmer does not fence the side along the river, what is the largest area that can be enclosed? Okay, so it's a lot like the last problem. It's just that this side doesn't need any fencing. So we can use the entire amount of fencing for just 3 sides. So I'm still going to label it X and Y. And that'll be X up there. We're assuming that the river is perfectly straight. It's probably not, but oh well. So I'm going to do the same type of thing. Set up a perimeter equation. So 2x plus y is equal to 4,000. Okay, so that's all we're going to do with it for the moment. So now what is the largest or the maximum area? So give me an area equation. Well, it's the area of a rectangle still, so x times y. And again, you need to get your area in terms of just x or just y. So go back to your perimeter equation and solve it for either x or y. Now, you want to be as nice to yourself as possible, so choose the easier variable to solve for. So in this case, it's the y. You can solve for x if you want. You're just going to create a fraction if you do. So 4,000 minus 2x. Now that you know what y is, you can plug it into the area. And since it's factored, you can do the intercepts again. So your intercepts would be at 0 and 2,000. Which means the vertex is right in between at 1,000. So max area occurs when x is equal to 1,000 meters. So now this question didn't want to know the dimensions, so you don't have to tell me the height of the rectangle. You can if you want, but it's not asking for it. It just wants to know what is the largest area. So you can take your 1,000, you can plug it back into the area. And then just calculate that. You can find the y if you wanted to, and then just multiply the x and the y together. Either way, just as long as you're answering the question they're asking, that's what you want to make sure of when you do this. So if you work this out, you get 2 million meters squared. All right. This next example, Josh is standing on top of a cliff and throws a rock towards the ocean. The path of the rock is modeled by the function negative x squared plus 14x plus 120. Part A, at what horizontal distance from the face of the cliff is the height of the rock a maximum? So in other words, it wants to know the vertex. Oh, I also left this out when I typed it up, but where y and x are in feet. Okay, so what horizontal distance is the height of the rock a maximum? So it wants to know, using this function, where does it reach the top, or where does it reach the vertex? So again, you have 2 ways. You can either find the x-intercepts, which would be a little difficult with this. This is not really a whole lot of fun to maybe factor. Some people get freaked out when this number is big. So let's use the other way. Even if you be in class raising your hand going, I know what it factors into. Well, just keep it to yourself. Okay, so we're going to use that negative b over 2a. Just so we can use it and you can see it. Okay, so that would be negative b, so negative 14, all over 2 times a negative 1. So it's 7. So when x is 7 feet, that's when the rock reaches the top of the parabola. Okay, b, find the actual maximum height. So when x is 7, just plug it in. And work it out. So that'd be negative 49 plus 98 plus 120. So that is 169 feet. So that's the highest the rock is going to go. Okay, part C. At what horizontal distance from the base of the cliff will the rock hit the water? Well, this is a little different because this isn't really asking a question that we've seen before. Okay, so all we know is that this y value, that's the path of the rock. So the y value, or this equation is giving us the actual height. So we know the height of the water. The water is at a height of 0. So we don't usually like to factor to solve a quadratic when the a value is a negative. So flip all your signs. So essentially you're multiplying everything by negative 1. And then you can factor it. X minus 20 and x plus 6, which means x is equal to negative 6 and a positive 20. So for these values, you can't have a negative distance. So we're going to keep the 20. So it's 20 feet away from the base of the cliff when it hits the water. So as a visual aid, here's your cliff, here's Josh. So he throws a rock and it's going like that. So this distance is your 20. The vertical distance up here, that was your 169. Okay, D. When the height of the rock is 160, how far is it from the cliff? Well, it's the same kind of problem as it was in part C. It's just now instead of the height being 0, it's 160. So don't start to solve or start to factor or use the formula or even completing the square until your quadratic has been set equal to 0. So let's swing everything over to the left to make your x squared positive. So x squared minus 14x plus 40 is equal to 0. And now you can start to use your quadratic methods. So x minus 10, x minus 4. So x is equal to 4 and 10. And we can keep both of them because they're both positive. So how do you have two answers? Well, it's because it probably hit 160 feet on the way up, and then it hit it again on the way down. Okay, so that is going to conclude section 3.4 and also this first big ol' unit for the class. So go ahead and try the homework out. And for the homework, especially like in this section, if you need to use a calculator, because you might have some interesting roots, because the book is assuming that you've got a calculator. So I don't mind if you're using a calculator and stuff on the homework. You just can't use one on the exams. So the exams are written to where you're not needing to know the decimal approximation for like the square root of 5 and stuff like that. So everything is just, it's exact. So the numbers come out a little bit nicer. So if you need to use a calculator in the homework, feel free. Just don't be really dependent on it. So if you have questions about that, please ask me. And yeah, we'll go from there.